Hello everyone, first of all, congratulations to us Indians as we have launched our next mission, that is Aditya L1 Mission. So this is the first mission towards Sun. Though previously other countries have sent their own missions towards Sun, that is Parker Solar Probe of US in 2018. Okay, and now it's our Aditya L1. So first of all, what does this mean by L1? What does that L1 means? So this means a Lagrange point. So question arises that what is the Lagrange point? So let's understand that with the help of a small clip. So see, Lagrange points are actually the positions in the space where objects sent there tend to stay put. So whatever objects we are sending there, they will be in the state of stability, right? Just a sec. So just like this, Aditya L1's position is here. This is the Lagrange point 1 where Aditya L1 mission is going to reach, and it will take approximately 4 months for our mission to reach at this point, right? Okay, so I was telling you that why this position provides stability, why these are the positions which provide stability, because the gravitational pull of two large masses, that is, what are the two large masses here it is, one is Earth, other is Sun. So these two large masses का जो gravitational pull है, that becomes precisely equals the centripetal force which is required for a small object to move with them. So this here the force becomes equal, and that provides stability to this position. So this is just one position. There are other positions as well. And what is the advantage of these positions? Why do we want to? One is it provides stability, and other is it helps us reduce our fuel consumption, right? Because it will be automatically moving in that in that area, because there is already that stability provided, and it will be moving. Just a sec. It will be moving along with the revolution of the Earth around the Sun. Okay, so just have a view of this clip, and you will get. So see, I told you that there are other points as well. So those are Lagrange point 2, 3, 4 and 5. Okay, just wait for a second again. So this Lagrange point 2 which I just told you, that is the point, this one. Yes, this one is the point where James Webb telescope was placed. James Webb, you remember US James Webb telescope, that was placed here, though Aditya L1 mission has been placed here. Okay, so yes, one more thing, that why we have placed it here is that this point is actually between Earth and Sun, where it will be getting full exposure. Just a second. Yes, so this point is something where it will be given, see, this is the Lagrange point, this is Earth, this is Sun. So it will never be in the shadow zone. It will always be it will always be able to observe Sun, and Sun will not hide from this Lagrange point. So that's why we have chosen this position. So it can act as a solar observatory in a better manner at this place, right? That's why we have chosen Lagrange point 1. Okay, so now let's go ahead. Since we are studying about Sun, so okay, let's since we are studying about mission related to Sun, let's understand sun a bit. So see, sun, just like earth has layers, sun also does has layers. Like, it does have layers. One is, so the internal layer, this one is called core. Then we have this radiative zone. Then we have this convective zone. Then next layer which we have is photosphere. This is the outer layer. So this is the inner layer, this is outer layer, and then we have one transition zone, and then the last layer. So outer layer mein we have photosphere. This one is photosphere. This one is chromosphere. Then there is a transition region between chromosphere and corona. So this is corona and this is chromosphere. Between them there is a transition zone. So okay, you got that. But why I'm telling you this is, why these layers are there? These layers are there. With these layers, the temperature of the sun changes. See how? See here. Corona is too hot, right? Then if we see photosphere, the temperature is around 10,000. Then the temperature starts reducing a bit. Then it again increases again. Then there is maybe this. Then there is a transition zone where the temperature is a bit kind of stable. There's a transition zone where temperature is again increasing actually, sorry. So again that the temperature is increasing continuously after this layer, and that too very fast. Then further in the corona, the temperature continuously increase, and it is the hottest layer. Okay, where we have temperature up to this. Okay. So you can see that the temperature was this, it reduced, it again increased. So like that. So why this is happening? Why the temperature inside a bit of earth, that is here. At photosphere we have less temperature, then at chromosphere it increases, then again at corona it further increases, while here we have high temperature at the core. So why this is happening? There is not a particular answer to this question, and we are further, scientists are further working on this, and Aditya L1 mission will also try to understand the reasons behind this. Okay, so yes, let's go ahead and okay, so this is a short summary of Aditya L1 mission. See, it will be studying sun, you all know. I told you one other mission of US, that is Parker Solar Probe. It will be having 7 payloads. Out of that 7 payloads, 4 will be remote sensing, and the other 4 will be in situ. They will be doing in situ observations. Okay. So this mission, as I said, that there is a Lagrange point 1, here we have Earth, here we have Sun. So this distance between Lagrange 1 and Sun is 1.5 million kilometers. So this distance is this. Then what are the things that it will be able to study? It can understand on the the activities of solar flares, how they happens, why they happens, the weather or climate on the earth getting affected, and global warming, etc. All that can be furthered by this study. It can help us understand these things as well. Then it will also help us maybe innovate some technology for solar energy with the help of the mission. And what are the basic objectives of the mission? So basic objectives of the mission are understanding the coronal heating problems, study dynamics of the solar atmosphere, origin of coronal mass ejection. So you must have heard about coronal mass ejection. If not, just, if in short I tell you, then these coronal mass ejections are large-scale eruptions of charged particles and magnetic fields from solar atmosphere into space. And we also face some disadvantage because of this, because they can disrupt a range of ground and space-based technologies and satellites on the Earth. So yes, and similarly, we also face some solar flares or solar winds from the Earth, from the sun. So solar flares are what? These are also kind of these are localized eruption of electromagnetic radiations in the sun's atmosphere, and they occur in a span of 11-year cycle usually, and they might they can be accompanied with coronal mass ejections sometimes, or they may not be accompanied with it. So yes, these are the things which we face from ejecting from the sun. So that origin of this coronal mass ejection is what Aditya L1 mission will be studying. Then solar wind distribution and temperature animosity, as we said, that why the temperature is changing and all, the way it is changing, that it will study. And yes, these all are the objectives. So these are the objectives which it will be studying. So that's it about Aditya L1 mission. If you have any queries, you can ask in the comment section. Thank you.